All right. Hey, good morning, chemistry class. I'm in my comfy clothes right now because it is freezing out. So I want you guys to make sure you stay warm and stay comfortable. Um, if we're looking at what I want you guys to do today, asynchronously, I want us to finalize our study guide. I want you to get something solid that you can study off of for our test, which is, of course, tomorrow. So this video, what its point is we're essentially going to be going through the study guide together. So what I'm going to do is I'm going to share my screen, and we're just going to take it slide by slide and walk through this. So part one is just basic electron configurations. This right here, this what I took out, this is just a chunk, right? This is just one little piece of a total electron configuration. In fact, we can see it right here in the electron configuration. So I took this chunk out and I wanted you to label each of its parts. Well, this first number, of course, remember, this is our energy level, like energy level. And of course, what that basically means is it's just the floor, right? What floor are we on? And you know what? Now that I'm seeing this, I'm just going to type it. So this is our energy level, our floor. All right. Of course, the letter that's sandwiched between the two numbers, this is going to be our sublevel, which is actually just like a room, right? It's just like our room that's on the floor. And then finally, the exponent, this is going to be the number of electrons. You're going to have to forgive my typing. My hands are still a little bit cold from the drive this morning. Number of electrons. When we're looking at this electron configuration, this person did make a mistake. What they did here, and I'll show you P table, they went to 1s2 to 2s2, that's correct, 2s2 to 2p6, which is correct, to 3s2, still good, 3p6, perfect, to 4s2, which is great. But from 4s2, they jumped to 4d1. Now remember, when we're looking at our periodic table, yes, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, but this is not 4d1. This is 3. Remember, this is 3d1. So we start at 3 once we get past that 4s, remember, because of that lower energy. Right? So 3, we start at 3 when we get to that block. So should be 3d1, not 4d1. Okay, this energy level table, this is something we covered in class. I'm not going to type it back out. Make sure you have it matching exactly what I have here. Now, the question this relates to on the test, I'll let you guys in on a little secret, is basically this. If I asked you on the third energy level, right, our third energy level, n equals 3, our third floor, what, excuse me, I got something in my throat. What subshells exist on that energy level? What sublevels exist? So on that third floor, we see, oh, we have an S, a P, and a D. So my answer would be S, P, and D, right? If I asked you for the second floor, what sublevels exist, you would say S and P. If I asked you for the fourth floor, of course, you'd say S, P, D, and F. Or if I asked you for the first floor, your answer would just be S, right? It would just be S. Okay, next one, we're going to do the electron configuration for our friend chromium. All right, so first we have to figure out how many electrons are in chromium, and of course we're going to find that in the periodic table. Chromium right here is element 24. It always has been and it always will be. Now, is it an ion? We have to check. Nope, it does not say it's an ion. So that means this chromium is neutral. It has 24 electrons, all right? It has 24 electrons in it. All right, write out the complete electron configuration. We're going to have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d, I think 4. But let's double check. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3D, 1, 2, 3, and 4. 3D, 4. So if we were to do the noble gas configuration, we need to look back at our periodic table and find out what was the last noble gas that we encountered. Well, if we keep moving backwards from our element, we find our last noble gases right here. It's argon. So our noble gas configuration is going to start with argon and then include everything else after that. So we're going to have argon in parentheses, and then we're going to have 4s2, 3d4. So writing that out, we see we have argon, and we have 4s2, 3d4. Very cool. Now, to save some time for the electron configuration, or the orbital diagram here, we just have to remember our rules. That's all I care about for this test, right? We have to remember our rules and how we place, the arrows in. So remember, each box has both an up arrow and a down arrow. You never double up on the same spin. The other thing is, I always go up in terms of energy, right? So I always go up in energy. So 1s, I have to fill that up before I jump up to 2s. Before I get to 2p, I have to fill up my 2s. And once I get to 2p, I have to make sure I fill every single box before I pair up. We're never, ever, ever going to pair up unless we have all the boxes filled. So in the test, it might ask you a question, right? It's going to say, well, what did this person do wrong? And in fact, we have this question here. What did this person here do wrong? Well, what they did wrong is they doubled up before they filled every single box with an up-facing arrow. So just to save time, we would end up at 3d4. So we'd have 4 electrons in this 3d shell, subshell, and what that would look like is this. 1, 2, 3, 4, just like that. Everything else before it would be filled. So we have up and down, we have up and down, up and down, up and down, up and down, right? Everything's filled up until we get to that 3D where there's 4 electrons, of course, and those electrons all are going to be in their own boxes facing up. All right, our next slide, I didn't ask you to do an orbital diagram because this one's a little bigger. This is palladium. Palladium is element PD. So if we find the number of electrons, we'll see palladium sits somewhere here in the middle. Here it is element number 46. All right, palladium is element 46. So we have 46 electrons to figure out. Right, we have 46 electrons. So let's go ahead and do this. If we're just doing it by looking at the periodic table, of course, we have our 1s2, usual, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d, 1, 2, 3, 4, 5, 6, 7, 8. So we end on 4d8, right? 4d8. So let's type that out. Of course, we got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and then it's 4d8, right? I already forgot what I had said. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 4d8. So here's our entire electron configuration. Super long, super clunky, tough to write out. What we're going to do is do the easier route. We're going to do our noble gas. So all we have to do is go backwards until we hit another noble gas. So we go through all these guys, and then we see the noble gas that we last encountered was krypton. So we're going to start with krypton in parentheses, and we're going to say, okay, krypton, which basically represents everything before krypton. It says krypton's electron configuration, everything before. And then we have everything left over. On our 5th level, we have 5s2, and then we have 4d8. So the way we write that out is going to be this way. We have krypton, and we have 5s2, 4d8. Just like that. Super easy. A lot better to write. All right, the excited state. Our excited state, what we're looking for is I want to make sure you guys understand what happens. How do we get an electron to jump up in energy level? And think about back to our flame test. How did we get that electron to be excited? What did we do to that? Well, we added in energy. Add in energy. The electron absorbs energy. Right? So when I put those sticks or those chemicals in the flame, right, I put that lithium chloride or that potassium chloride inside of the flame. That was me shoving a whole bunch of energy inside of those atoms into the electrons, right? But how does it get back down? Of course, once it gets that energy, what does it have to do? It has to release it, right? It has to get that energy out of it, and then it falls back down. So, releases energy. Releases energy. For this orbital diagram, the mistake that we saw, like I said earlier, is that this student decided to pair up before they filled up all the boxes. So this is incorrect. They didn't pair it up, right? Remember, or they paired it up when they shouldn't have. What they should have done is not write out this arrow here. So the best of my ability, I'll pretend to erase it and then have an arrow here. Right? So this would be correct because we had an empty box left. So we wouldn't pair it up. Now, if we had to add in another electron, that's when we would start to pair it up. But since we don't, right, we're only going to have 3 electrons in this 2p orbital. We would just keep them separated. Remember, always separate them before pairing up. That's what this student did wrong. All right, finally, this is a tough thing that we learned kind of at the end of the unit. Given the following electron configuration, how many valence electrons does this atom have? How many valence electrons does this atom have? Well, if we're looking, we see we have to look at our highest energy level. So what's our highest energy level, you ask? Well, we have 4 and 4. 4 is the highest level we get to. You're just looking at the floor number, right? The 4th floor is the highest we get to. So you have to take all the electrons on the 4th floor and add them up, and that gives you your answer. So we have 2 electrons in 4s, and we have 3 electrons in 4p. So we take those 2 plus that 3, and we find out we have 5 valence electrons. All right, next, does the fluorine atom gain or lose electrons to become an ion? Justify your response using the electron configuration or orbital diagram. So this is an important question for the test. You guys will need to use your camera or your video, your audio, and record yourself explaining this answer. So what we're looking for is fluorine is going to gain an electron, right? Because fluorine's electron configuration is only 1 electron away from a complete shell. That's something we talked about a while ago, right? Electrons on fluorine, right? Fluorine is just 1 away. It has 7 valence electrons. If it had 1 more, it would be a complete shell of 8. So it's only 1 electron away. It's easier to gain 1 electron than it is to lose 7, right? Excuse my typing, my fingers are still cold, but you get the point, right? It's easier to gain 1 electron than it is to lose 7, right? Because it has 7 valence electrons. All right, so that's our study guide. If you have questions, you can always message me on Schoology, watch some of these videos, but we will get through it. I look forward to seeing you guys tomorrow. We're going to take our test. Of course, you have a short week, so tomorrow's basically Friday for y'all. If you have any questions, feel free to message me. If not, have a wonderful day, and I will see you guys later.